So that leads us into this Modbus instance here. So we have a Modbus wall sensor. I'll show you a picture here. Let's go here. So if I go to asicontrols.com and I go to products, browse products, scroll down through the list. So digital display wall sensors, the overview. So both the WS-061, which has a RJ45 connection on the back, and the WS-MBS for Modbus, which has a screw terminal connection on the back, they both look the same from the front, but the connectors are different on the back. And so here's the WS-MBS data sheet, and kind of shows you here the Modbus registers. It gets powered by 5-volt DC, and it's got screw terminals on the back, so you need 2 wires for DC power and 2 wires for communication. And so the 9540 actually has a 5-volt DC power supply that can be used to power the sensor. If you use like a 9520, which doesn't have a dedicated 5-volt power supply, here's an example. You can actually use an input to provide 5-volt power to the wall sensor. You can't use it as an input for another, wired sensor, but you can kind of sacrifice that input to use it as a power supply. You would insert the included picofuse in the pull-up resistor slot for whatever input you're using to power the Modbus wall sensor. And so in your virtual training files, I think there's a PDF called APB-WS-MBS, which is the application bulletin for the Modbus wall sensor. And Modbus is actually one of the original open protocols. It's not as well defined as things like BACnet and LAN and other newer protocols, but it still gets used occasionally. It originally started in the industrial world and kind of worked its way into the commercial world a bit. It's still not the most common one, but sometimes there's Modbus gateways to certain kinds of controllers. I know like Carrier used to have a Modbus gateway. But some other Modbus devices that have been connected would be things like certainly our wall sensor. Some people do generator monitoring. There's lighting panels. There's VFDs. There's input and output modules. And so Modbus has just a few different types of objects or registers. And so let me just do a Google search here, Modbus registers. And so this is accurate here. So these are the types. There's coils, which are binary, normally related to output and can be read-write. There's this says input bits. I've heard it more commonly referred to as input status, which are binary input values that are read-only. They're not read-write, they're read-only. And then there's input registers, which are still read-only, but they are analog values, typically related to analog input. And then the last one is holding registers, and those are analog values, but they can be writable. And so everything in our Modbus wall sensor happens to be a holding register. And anytime you're doing any kind of Modbus integration, I would recommend that you get some documentation from whoever's providing the Modbus module that tells you what registers are available and what they do. And so for our Modbus wall sensor, this application bulletin would be the equivalent of that. Did I open this in? Yeah, no, I didn't open it. So this APB-WS-MBS PDF you could open with your PDF viewer. And so there's the wiring. And so this describes the different holding registers that are available. And Modbus is not very well defined in that some Modbus devices start counting from 1, what we're calling holding registers here, and other Modbus devices start counting from 0, which is what we call the register address in this column. And when programming our controller, you would refer to the register address. There's yet another way you sometimes will see the registers defined, and that's with kind of their absolute locations. So holding registers, let me see if I can find an online document. Holding registers are in the 40,000 range. Let's see if this one tells. Let's see. Let's call it holding register 40,000. Whoops, should be 40,000. How about coils, input, holding registers? Actually, maybe I'll just show it to you in our documentation. I know it's there. So in our object definitions file, which is help ASIC3 obj underscore ASIC3, there is a section on Modbus. And here it tells me coils are 0 to 99.99. Input status is 10,000 to 19,999. Holding registers are 40,000 to 49,999, and input registers are 30,000 to 39,999. So some documents might also show you the absolute locations. Most of the time, they're kind of just the offset without the absolute location. So that would be the way we show it to you. Whoops. Here. So if I kind of overlay this with the Modbus instance in the controller, I can get them sitting on top of each other. Put this down here, store this down, make it narrower, something like that. So a single Modbus instance in our controller can read up to 8 consecutive registers. And so the slave address can be between 1 and 247, I believe. And that is kind of the Modbus address on the local network. The start address says which is the first holding register that you want to read. And the number of registers says from that start address, how many total registers do you want to read? And you can read between 1 and 8. So this means start reading from register 0 and read 8 consecutive registers numbered 0 through 7. So if I overlay this, this tells me data 1 goes along with the override status parameter. 0 means that nobody's pushed the override button lately. Data 2 is for the clock icon. 0 means that the clock icon is not currently displayed on the wall sensor. I could write to this register by writing a 1. I could cause the clock to display. Data 3 is the set point in tenths of a degree. And so you can push the up and the down arrows to adjust the set point. And so this would mean the last set point somebody changed to was 75.0 degrees. Data 4 is the temperature display in tenths of a degree, so it's measuring 77.7 degrees Fahrenheit. Data 5 is the fan mode, which is a writable register. 0 means that the fan icon is not visible currently, which is usually meant to tell someone that the fan is not on. Data 6 is the control state, where the value of 1 is occupied. So if we were looking at the wall sensor, there would be a sun icon, which is meant to indicate occupied. There's a moon for night setback, and then if there's no sun and there's no moon, then that would be unoccupied with the value of 0. Data 7 is the control mode, where 0 means off. You could write a 1 for cooling mode, where you'd see a snowflake. You could write a 2 for heating mode, and you'd see a flame. And then data 8, 64, we kind of combine a bunch of secondary values into one register. So the 64 actually means just show the degrees, C or degrees F symbol based on the temperature unit setting, and we're currently in degrees F. So this document goes on to explain more about the various icons. I think there's actually yeah, so here's an example. There's the sun for occupied, there's the flame for heating mode. It gives you some brief programming examples. There's also this engineering mode. In the registers list, there are a number of parameters that can be adjusted from the wall sensor itself as long as engineering mode is not locked out. And so there's this operation mode, defaults to unlocked, but you can lock out engineering mode, which means you can't change these values from the wall sensor by getting into engineering mode. There's also lock user adjust, which would not allow you to change the set point from the wall sensor. Maybe you just want to use it as a display to show information, but not allow interaction in terms of making changes. And then you can also lock both the user adjustment mode and the engineering mode by writing a value of 3. So as long as the engineering mode is enabled, you can change these things from the wall sensor, where maybe the more common ones you would change would be the Modbus device address. We said it could be between 1 and 247. If you had multiple Modbus devices on one network, they would all need to have different device addresses, but the same baud rate and the same data format. And so there's some examples of reads. This actually, well, it's set for Celsius. I think that's why it's showing these lower values, 22 degrees C set point, 25.3 degree actual temperature. I mentioned there's some programming examples. So you might read the holding registers to see if somebody pressed the button. When they press the button, initiate after hours, and then you want to write to that register so that it resets back to 0 so that it can register the next push. Fan mode, if you had a 3-speed fan, then you could select a value between 0 and 4. So 0 means no fan icon, 1 means just the fan icon, 2 means it's the fan icon with 1 bar for low. Then you can, for medium speed, you can show 2 bars, and for high speed, you can show 3 bars. Control state, if you're using the state object, you can write a value between 0 and 2, depending on if you want it unoccupied, occupied, or night setback. Control mode, you can write a value between 0 and 2. 0 is deadband, no flame, no snowflake. 1 is cooling, show the snowflake. 2 is heating, means show the flame. For temperature control, you could read the set point from one register, compare it to the temperature in the next register. In this case, we're using them in 2 different PID calculations. There's also this remote sensor mode. So there's a feature called remote sensor enable. If you look in the register list, it's here. So by default, it's disabled, meaning the temperature display is reading the current value from the built-in thermistor. But if you enable the remote sensor mode, then you can actually write to the temperature display so that you can tell the wall sensor what temperature to show. And so one case of that might be where you have a stainless steel plate sensor in a refrigerated storage area. And on the outside of the refrigerated storage area, you want to just be able to show people what the temperature is in the refrigerated space without them having to go in and read a sensor or take a measurement. So then you could read that value from that stainless steel plate sensor in the refrigerated space and then write the value to the Modbus wall sensor that's in a more comfortable temperature environment so that somebody could just make sure it's not getting too warm in that space. And so it is important to know that if you're writing the temperature display, you need to write it in tenths of a degree, because the stainless steel plate sensor, we saw temperatures normally read in hundreds. So you can just divide by 10 to get it into tenths of a degree. And so that's an example of remote sensor enable here. So it's just dividing by 10 and sending out the value in tenths of a degree. to the Modbus wall sensor. And so those are some examples. If you ever use a Modbus wall sensor and you have more questions, let us know. I talked to you on Monday about how to contact us for support. So again, this class is an introduction. We want to show you a lot about the different things you can do with our controllers. So there's a lot of information. Don't expect you to remember it all. So it's important to know how to contact us for support so that you can get the information you need when you're ready. What I usually tell people is, we've been looking through some of the help documentation.
Hey, Mike.
So, yeah.
Can you put that contact information up for me one more time? I'm going to get a picture of it.
Sure. Okay. There you go. And so contacting us for support is helpful. I do recommend, to get familiar with our help documentation. And I'd say take maybe 10 or 15 minutes looking through it. You might find the information you need. You might find some information that you will find useful later when you're working on something else. And if anything, you'll at least get a little more comfortable searching through our help documentation. If you can't find the answer you need in the first 10 or 15 minutes, that's usually when I suggest you call us, as long as it's during our normal tech support hours. And by the way, I didn't include it here, but Chris Shope, I believe he starts at about 7:30 Eastern time. So then for about the first 6 hours or so, because 10:30 a.m. Pacific would be 1:30 Eastern time. So a big chunk of his day is doing tech support for, East Coast and Central Time customers. And then towards the end of the day, that's when I just kind of take over, so that the end of Chris Shope's day, he can close out cases or focus on follow-up and not taking in new calls. And so then actually this should say 10:30 to 1:30 as well. You might want to take a new picture. It's minor details, but more accurate now. And so then I get towards the end of the day. Most of our customers tend to be in the Eastern and Central time zone, so that but by 1:30 Pacific usually has quieted down a bit, because most people are ending their day. So if you can't find it in the first 10 to 15 minutes, contact us either by calling option 3. There's actually also an email address, a general one, techsupport@asicontrols.com. Again, you might want to take a new picture with a little bit more information in there. So call or email us. Let us know what you're working on. We might ask, for firmware versions or software versions in case we have a fix in a newer version. We might ask you to send us the configuration file from your controller so we can load it into one of ours and do some testing. And then we should be able to help you resolve whatever issue you're working through.
Hey, Mike, I got one more question.
Yeah. Sure.
With that help on the Visual Expert, is there a way we can access that without being on Visual Expert, or is it just on Visual Expert?
You can actually. I think it's easier to start ASI Expert and just go to the help menu, but all it's really accessing, if you were to go look on your computer, if you go to C, ASI Controls, there's a help folder, then the different help files are all organized here.
Okay.
And so it's really just breaking out folders. But I think it's easier to navigate by just starting ASI
But that's
Expert.
still, those folders are still coming off of the Visual Expert, right?
Correct. Yeah. So once you install ASI Expert, these files will all be here. And so even if your license timed out or something, you could still find the files here. We're not going to erase the files when the license times out. But I do find it easier to navigate from ASI Expert, because then I don't have to open different folders and whatnot. So I think we're getting towards the end of today. And what I like to do towards the end, and certainly let me know if you have any questions. You can either just ask verbally or put something in chat. I like to go through just some of the icons We've used some of them, and then you might be curious about some of the other icons. So I'll just start going from left to right. The system options is only available when you're not connected to a controller. So if I go to the home screen, actually it's not available for a BACnet project because it's mainly meant for like COM port connections. But if I go to project browser mode, now it's lit up. That's where you can select like COM ports and stuff like that. Print screen normally prints what's on the right side of the screen. So let me just go back and open my project. October 26th, 9505. So it tends to print what's on the right side of the screen to your the default printer within your Windows operating system. So if I click there, I mentioned that I have a PDF printer driver by default. So it's going to ask me to save it as a PDF somewhere. Save, creates the PDF. So you can see it's just basically showing what was on the right side of the screen. It'll kind of stretch and skew, so landscape orientation is probably better than portrait, but you get the gist of it. Project Browser brings you back to the opening screen that you see when you first start ASI Expert. And so this is the folder it's looking in, and these are all the subdirectories it sees with various projects. Most of these other icons are only available while a project is open. So I'll go back to my open project. The telephone icon is only it stores a telephone list, so I don't think you're going to be connecting through many modems. The binoculars is also for ASI protocol only. You can search for a range of addresses. Since ASI protocol doesn't support discovery the way BACnet does, sometimes you just want to tell ASI Expert to search for a range of addresses. So I'll open an ASI protocol project like my COM port project. Not actually going to search, but if you click on the binoculars icon, you can search for a range of addresses there. Let me go back to my main project. Project reports, it's kind of a neat feature. I don't think many people use it. It's one of the few ways you can get ASI Expert to show information from multiple controllers. So you can actually create custom reports that look for, all your inputs, all your outputs from all of your controllers. You can build your own. If you're ever interested, let me know and I can walk you through it, but I don't think most people use it. If you ever want to get back to normal views, you can click on the hammer and the screwdriver. It's not going through. Let's see what happened there. Let's go back to 9505. That's online. So we know about save as, and load. That's the save files from the controller onto the computer, and load is to take a file from the computer, push it into the controller. These DOS icons you'll never use. Back when ASI Expert was first created, it was a transition from an old DOS-based programming environment into Windows, and so this was to let you work with some of the older files, but it's been a long time since we've used those. Home just brings you back to the initial screen. In BACnet, that's the discovery view. In the ASI protocol project, it's what we call the find it screen, where you can enter a new address. Configure device lets you, if you've got some alternate views here, and configure device brings you back to the kind of the default views. So let me go into my 9540. So this generate report's kind of a one-way export that saves all of the green labeled parameters in a big CSV file. If you're doing an electronic O&M manual, it's something you can include if you want. So when I click it, it says, okay, you want to save a configuration report. By default, it goes into your local project folder. And then the file name is A2 for programmable controllers, 9540 is the model number, 9505 is the ASI address, and it's a CSV file, comma separated variable or values. And so if I go look at that file, in my local projects directory. October 26th. There it is. So it's that's a pretty good size CSV file. And it's going to have lots of rows in it. And so it just goes by object and index. So object 1 is the system object, and just basically tells you what the setting is for this parameter name. And so if you go all the way to the end, it's almost 5,000 rows. So it's a pretty big CSV file. It's a one-way export. You can't import this back into the controller, so it's meant as kind of a one-way dump. Go back. And the next one is handle view. I don't think you'll use it often. That was kind of the precursor to real graphical programming. So if you selected an instance in the Objects tab and click on Handle View, then it'll show you, that's what we call the focus item, and it'll show you what's linked out from that item and what's linked into that item. And then you could double click on another instance and it'll make that the new focus item and show you what's coming in from the left, what's going out on the right. With graphical programming, you don't really need this view, but it's something we had. We never took it out. Hammer and screwdriver again gets you back to the normal views. Allocation view, we looked at that. That's where you can change the objects that are available for use and how many instances for each object are available. Remembering that reallocating or changing the allocation does cause the controller to reset, which turns all the outputs off briefly. So be prepared or don't do it unless that's something that's safe to do. Hammer and screwdriver for configure device gets us back to normal views. We've used auto trend. There's this pencil icon to edit layout. You can actually change what's shown on these screens. We don't generally recommend it that end customers do it, because when we release a new version of ASI Expert, sometimes we'll change the screens and we don't want to overwrite some screen that you've customized and now it's gone. But I mentioned, let's see, there are a couple of things on my list here. Like I said, on the output setup tab for the PID object, there were some parameters that didn't belong. So these three parameters shouldn't really be shown here. So once I send that report off, what somebody's going to end up doing is going into the edit layout mode, finding the output setup tab, and then to delete an item, you just click and drag like you're going to reposition, but there's this trash can lower right. So someone's going to do probably something like that. And then you click save when you're done, and now you won't see those anymore, and they'll build that into the next installation version. You don't need to worry about that now, but just want to show you one thing you could do while editing the layout. So going through to the menus, a lot of the menu items have toolbar equivalents, toolbar icon equivalents, but project new lets you create a new project. I don't usually use that because when I want to create a new project, I usually just start in project browser and double click here to create a new project like it tells you to. Open lets you open a project, and so the files you can expect to see when you're working with ASI Expert, if you start from see ASI controls projects and look in a directory, there will be usually one MDB file, which is like an Access, Microsoft Access file. We use actually an older version of the Access MDB format. So be careful if you're ever trying to edit them manually. But this MDB file doesn't contain a lot of programming information. It, for the most part, just contains the information needed to build the tree on the left. So October 26th training, basically it has the name of the project and like the controller model numbers and addresses and descriptions. It doesn't know about how many PID instances there are and what the control set point awk is and stuff like that. There will also generally be at least one .asi file for every controller in the tree, and the .asi file is the one that contains the the details about the programming in terms of set points, personalities, input, output names, all those sorts of things. Then if you've ever exported any CSV files, they'll be there. If you've created any, backup folders or other folders that contain .asi files, they'll be there. And then these log files, you'll get one log file per month. You won't usually need to open it and look at it. We won't usually ask for it, but ASI Expert will occasionally write some information into those log files. So if you're ever to open a project, it's basically saying, go find the MDB file that has your project. Save and save as here is just saving the project, which is saving the MDB file. Desktop shortcut, you can actually create a shortcut on your desktop that you can double click on to immediately open a project rather than starting in Project Browser and having to find the project. And then Quick Launch shows you some of the projects that were recently opened. If you're not sure where you save them, that might help you find them. Options, everything we've done is in what we call expert mode. There is also this user mode that we used to use years ago as a real basic front end. It's not commonly used these days, but you could actually create your own tabs that show just the information you wanted your customer to see out of the controller. There was ways to do some simple animations and put some background images, but that was before we had, better front-end options that are, browser-based and whatnot. So I don't think you'll use it very often. View preferences is probably the most important thing here. So there's this parameter page cache, which ASI Expert will try to remember some information about controllers that it had recently communicated with. It doesn't have to go recheck the same information over and over again. And so with disks being larger these days, there's probably no harm in sliding that all the way to the right to the largest setting. And then probably the most important setting here is this one we call auto save mode, with the description of always synchronize disk archive. And so I like having auto save mode on. And what happens then is that anytime I'm done talking to a controller, ASI Expert just saves the most recent copy of the program on my computer. And the only real downside to that case is it can overwrite a file that had valuable information in it. But that will only happen if you open a project, connect to a controller with the same address, and then it'll save because the default file name is based on that address. And so if you only open projects to talk to controllers within that project, usually you won't have that problem. And a lot of people end up creating a kind of a dummy project like test or junk or workbench or something like that. So if somebody brings in a controller that they want you to do some troubleshooting on, you can just connect in that project that doesn't have a lot of valuable configuration files, .asi files, and then you don't worry about overwriting them. I will show you what happens when autosave is not set. So if I deselect that and click OK, go to my controller. And so now actually I don't even think I need to change anything. I think if I just exit out from the controller, yeah. So if I just go back to the home screen, when autosave was on, it just automatically saved the most recent programming. But with autosave off, now it's saying, well, do you want to save the device configuration file? And by default, it's going to choose a default file name in the project folder. You could choose a different location if you wanted, or a different file name. So if you click save, then it'll just save it as if it would when autosave was on. If you click cancel, then it won't save. And that's the option I don't like, is not having the most recent controller programming on my computer. So that's why I like autosave on. I'll just click save here. You get a prompt. Do you want to replace the existing file with the same name? Yes, I do. And what you'll see is it'll read some information in the lower right. Then towards the end, you'll get the yellow bar all the way across the full width of the screen. So the initial saving is just reading all the object stuff. That's the narrow yellow bar on the right. When you get the big yellow bar on the bottom, that's when it's saving the function group, the graphical programming portion, into the controller, because that's a different process. Also, when autosave is off, that applies to saving the project, which again is basically the tree information. So I'll just find one of the other controllers here, like 9502. And I'll click OK. And I'll go home. Prompts me, do you want to save? Yes, I do. So that's no different in terms of saving the .asi file. But also when autosave is not on, if I exit out from the program or return to project browser, it's going to say, do you want to save the MDB file? And that's saying, do you basically want to save all the latest information I used to build the tree, so that when I reopen the project, it contains all the controllers that you currently see. So if I click no and reopened, I wouldn't see the 9502 project or controller because it did get saved in the MDB. And I'll just show you that. If I click no, I don't want to save it. If I come back to my October 26th project, I don't think I'll see 9502, so you can see it wasn't there. So that's why I like autosave. Again, it just makes sure that you always have the latest programming from the controller stored on your computer, which I think is generally a good idea. One other setting in here is this function groups, print preference 1, 2, or 4 pages. And so I'll choose 1 page to start. And notice it says landscape mode for 1 page. When you choose 2, it says portrait mode. When you click 4, it says landscape mode. So I'll click 1, click OK. And so I mentioned when you're talking to your controller and you're in the Functions tab, then when you're doing your programming, there are horizontal and vertical scroll bars. So one of your options is to print these screens out. So if I'm looking at this cooling and heating group and I click the print icon, printing a function group does actually let you choose the printer. Most of the time when you choose the print icon, it automatically goes to the default printer within Windows. But in this case, I'm going to go to this PDF printer driver. I'm going to make sure I'm in landscape mode by going to Properties, Pages, Landscape. And so now if I click OK, since it was 1 page, cooling and heating, new. And so you can see that printed it all on 1 big page. So that almost requires 11 by 17 minimum as in terms of the size of the page or the size of the paper that you're printing on. This wouldn't be real readable on 8.5 by 11 landscape. So if you were to choose a 2-page printout, and I'm just going to do something like this just so I can mark it up. So if you chose a 2-page printout, then it would break it up into 2 pages, something like vertically, something like this, and like that. And then if you chose the 4-page printout, then it would break it out into 4 quadrants, something like this, and then that, and then that quadrant, and finally that quadrant. So the portrait is good, and the 2-page is good for portrait because it does basically a left and a right, and then that works. That's pretty readable on 8.5 by 11. But if you want to make it a little bit bigger, you can choose the 4-page printout, and then it'll print them in 4 quadrants, and that works better in the landscape view. So that is the print preference setting. That and that, minimize. One other thing, not directly related to toolbars, because I think that's most of what I want to show you from menus and toolbars. But one other thing I want to show you before we end is if you right-click here on the left side, actually before I do that, I'm going to right-click on the right side. If you right-click on the right side while viewing a function group, it gives you an option to save as bitmap. And what that does is it will save a large bitmap with the name of your function group into your project folder. Bitmaps don't compress, so the files are pretty big. They're color, and it's, I think it's like 2000 by 1500 pixels. So that's a 6 megabyte file. Not huge, but pretty big for an image file, and that's because it's not compressed. And so that is one way you can get an image of your program that you can share with someone else that maybe doesn't have ASI Expert. I don't usually use the Save as Bitmap option, though, because I think a better way to get pictures is to go to the left side of your screen where the names of your functions are, and then do a right-click Generate HTML. Then it kind of cycles through all of your function groups. And if you go to your project folder, you'll have an HTML folder that has a directory with the ASI address of your controller. And then there will be an HTML file and a JPEG file for each of your function groups. And then there will be a single index HTML file that you can open with a browser. Then it has the ASI address and the description, got some information from your license, got a date, and then there's these links to the JPEG files for each of the projects that you have. So you can click to see that one, go back to the index, cooling, heating, back to the index. So this is another way that you can create images of your programs to maybe share with somebody else that doesn't have ASI Expert. So that's a pretty easy thing to do that you can also include on an electronic O&M manual. Let's see, what else is here? There's also some options when you're right-clicking on the right. Show tips gives you a little bit more information about each icon and what handles are connected. I don't usually turn that on, and when show tips is turned on, you can't make new handle connections. But you may find that useful if you're not sure where all these various points are connected to. Show types has to do with the information, the second line of text below the icon, which I like to see. But if you turn show types off, that goes away. I like show types on. Show bold text. If you have a very high resolution display, show bold text kind of changes the text for those below the icons. I don't care for that font, and I don't have a big high-res screen, so I don't usually show bold text. Show opaque text, where opaque is the opposite of transparent. It really only matters if you have like two items overlapping. So when I'm not showing opaque text and I overlap things, my text has kind of a transparent background. If I show opaque text, then my text has a non-transparent, in this case, white background. So I just try not to overlap things, and then the opaque setting doesn't really matter. Show flow indicators. If you've got a lot of lines on the screen and you're finding them difficult to follow, I just try to get these lines straight again. Show flow indicators puts little arrows on to help you follow the lines from left to right. I try not to position my icons too far away from the icons. It's not always possible depending on how complicated your program is. But I just think it makes the screen look a little busy, so I don't usually show my flow indicators. We looked at Save as Bitmap, and so we're getting right close to 1:30. I think the last thing I'll show you, if you just go to the Objects tab, there's this BACnet remote object, which from the object overview, I described as a way to share data with other BACnet controllers. And so there were some pre-programmed into these controllers. So this first one called VAV Zone Temp is reading the temperature from the VAV controller. So on the Read Property tab, I can see that index enable is yes. The interval is 5 seconds, meaning it's reading every 5 seconds. The remote device is the BACnet address of the controller I'm reading from, 116.105. And on the BACnet remote tab, I have the option to choose a read on interval, or alternatively, I can choose write options if I want to write to the controller instead of reading. The remote object means what BACnet object am I reading from, analog input. Remote instance means what instance of the analog input, in this case, am I reading from analog input instance 0. I mentioned that BACnet has various properties where present value is usually what you're interested in. So in this case, I'm reading the present value property from analog input instance 0. And so you can see it's reading every 5 seconds. The remote value has a decimal in the right place. It does convert it to a local value without a decimal if you need to use that in programming. There's a similar read on the RTU zone temp, and they're probably actually the same because I have another remote that's taking the RTU temperature and writing it to the VAV. And that's because the training kits have one WSO61 that when we're doing in-person training, we just plug the sensor into whatever controller we're programming. Since we can't easily change them and I didn't connect a second sensor, I'm just using one sensor and sharing them between two controllers. So the RTU zone temp read is similar. The remote device is different though, because that's the BACnet device address for the 8100 controller as opposed to the 6100. I'm also applying scaling here so that it divides it by 0.01 so that I can see the decimal value. So the local value is essentially in hundredths of a degree here. And then the next one you probably won't need to use often, but this is a write. And if you go to the write property tab, we're actually writing a value of 1 to analog input instance 0, but in this case, we're writing to the out of service property. And that basically means take the analog input out of service to overwrite it so that I can then send a value to the present value property. So in our controllers, and I think this is typical for most BACnet controllers, you have to take the input out of service before you can overwrite it. So this one's just writing every 29 seconds. It's saying, hey, go write, take the analog input 0 out of service, because this next BACnet remote instance, write VAV zone temp, every 11 seconds, it's writing to the analog input 0 present value, and it's looking at the value from the RTU zone temp reading, and then it's also applying scaling of 0.01 so that I get the decimal in the right place. So it's reading 7671 from the RTU zone temp, and then it's formatting it in a decimal format because that's the way that it needs to be written in BACnet. So that's just some examples. Both the Modbus and the BACnet remotes are examples of data exchange with other devices on the network. So you may need to do that from time to time.